Good morning, children. How are you all? Welcome. I hope you are safe and secure. Welcome to our Regina School online classes. Okay. So in today's class, we will see what is inside atom. Okay, na? From this chapter, see here, children. I am showing you a periodic table. So what you are observing here, different elements. Okay. See here in the first column, hydrogen, that is hydrogen, lithium, sodium. Okay, all these are elements. That means nothing but each element represents single atom, individual atom. So see here different atoms. Okay, now so from these elements or from these atoms, what really is varying? Okay, we all know periodic table different sections are there, like different blocks, S, P, D, F blocks. Okay, now so what is the difference from one element to another element? What really is varying? How we are able to differentiate those things? That is especially what are the changes in the characters with respect to atoms. Each and everything is atom made up of, but based on how the variation is. Okay, now in order to know that, we will see atomic structure. If you know how the atom is, then we can differentiate all the 118 elements. Okay, now now we will see atomic structure. Okay, now that is what is inside atom means nothing but what really is present in the atom, or that is atomic structure. We will see. Okay, this is an atom simply. Okay, now this small circle represents nucleus, children. Okay, now nucleus means inside the nucleus what is present, ma? That is protons and neutrons. Okay, now inside the nucleus protons and neutrons. So red color, that is protons. Okay, now children, and black one, that is neutrons. Okay, now they are neutrons. Now this is the nucleus structure, but around the nucleus we all know electrons will be rotating. Okay, na amma, around the nucleus manaki em untayi, what will be there? Electrons will be rotating in a definite path or orbit is called as shells. Okay, na? Around the nucleus, electrons will be rotating in a definite path. That path is called as shells or orbits. Okay, na children? See here I am writing shells or orbits. Okay, na? You can call it as shell or orbit, main shell. Now we will discuss about the charge of these elements. Protons are having positive charge. Okay, na? Protons are having positive charge. Electrons are having negative charge. Okay, na? Electrons are having negative charge. And the neutrons. What about neutrons, ma? One more particle is there, na? What is that? Neutrons are having neutral charge. There is no charge for neutrons. Okay, na? See here, I told you that electrons are revolving around the nucleus. Why it is revolving like that? Because there is a force, there is a balance of force between the positive and negative charges. Okay, now there is a balance of force between positive and negative charge. That is the reason why electrons are moving around the nucleus. That is, okay, na children? Now come here. See here, hydrogen atom. Okay, now look at these atoms. Atomic number, if you observe, some atomic numbers as well as atomic mass was given. So how to represent this atomic number and atomic mass for an element? If you observe this periodic table, on the left corner side, okay, left bottom, left corner top and bottom, numbers were given. on the left corner for an element, or atom, on the left corner side, top and bottom, an element number was given. What are those numbers, what it is representing? Okay na, we will see the things. Okay na children. Now see ma, for example, look at here, different elements: aluminium, copper, nickel, cobalt, okay, iron. All these are having some numbers. Okay na, what really are those numbers, that we will see. Okay na children. Next, copper. So if you observe on the top, a number was have you observed a number? What it is actually? Atomic mass. On the bottom side, what they are representing? That is atomic number. Okay na, see here, I will show you. Let us represent a number, an element, okay, x. Let us represent an element x. Let us represent an element with a letter or with a symbol x, for example. Okay na children. Next, on the left corner, left bottom corner, okay, left bottom, so left hand side bottom. So what I am representing a number here. Okay na, see, with a small box I indicated. Okay na children, are you observing? Whatever the number I am writing here, that is atomic number. What is it ma? Atomic number. That is, atomic number is equal to number of protons. Atomic number is equal to number of protons. Okay na children. If you move to the upwards, that is in the same left hand side, okay, left hand top corner. So there we will write a number. That number is atomic mass. One more point, that is atomic number, that is number of protons, is represented with a letter Z. Okay na children. Atomic number is represented with a letter Z. Okay na. Now where these protons are there, I told you na, inside the nucleus. Protons are having positive charge. Suppose carbon atomic number is 6. If I say that carbon atomic number is 6, that means in the carbon element there are 6 protons. Okay na. Next, see here, I am writing another atomic mass number, where I am representing atomic mass. Have you observed? Left hand top, okay, left hand side top corner. Okay na, left hand side top corner, I am representing the atomic mass. Okay na, atomic mass number. What is atomic mass? Atomic mass means mass of protons plus mass of neutrons. That is, number of protons plus number of neutrons together, or sum of protons plus sum of neutrons will give you atomic mass. Atomic mass number is represented with a letter A. Atomic number is represented with letter Z. Atomic mass is represented with a letter A. Okay na amma? Inte kada? Sum of protons plus neutrons will give you atomic mass. Now see here children, with the periodic table, if you observe, okay na, if you observe the elements, how the atomic mass and atomic number is varying for elements, given elements, that we will see here like this. Okay na, for example, I took carbon atom. Okay na, carbon atom, its atomic number is 6. Okay na, 6 upon left corner, left top, what I am writing? 12. Okay na, carbon, I told you na, carbon atomic number is 6. That means 6 number of protons are present in the nucleus. Okay na children. And 12 mass number is representing that 6 protons plus 6 neutrons are present in the nucleus. So that is atomic mass. Okay na? Okay na children? See here ma, 6 protons plus 6 neutrons. Okay na? From where you are getting this information, that is 6 protons and 6 neutrons, which I wrote here, that is from atomic mass. Okay na? As the force should be balanced between protons and electrons, how many electrons should be there? Equal number of electrons should be there, that is 6 protons, 6 electrons. Okay na children? Next, nice. Which element ma? Sodium atom. See here, sodium atom is represented with a symbol that is Na. Okay, right? These are Greek words. Okay, Latin names they have taken, that is natrium. Okay, na? That is why its a symbol became Na. So 11 protons will be there, that we are saying with the help of atomic number. Okay, na? Next, 23 atomic mass. Atomic mass is 23, that means 12 neutrons. So already we know 11 protons, that is from atomic number. Extra one more neutron is present in the nucleus. How many electrons should be? So equal number of negative charges should be in order to balance the positive charge, that is, so 11 electrons, 11 protons and 12 neutrons. Why it is more, that we will see. Okay, instead of getting 11 neutrons, why it is 12, that we will see. Okay, it has a specific name to indicate. Okay na children? Okay na? Next, iron. Okay na? Its atomic number is 26, that means 26 protons. 26 protons. Next, okay na? 56 minus 26, how many ma? What is the number? That is 30 neutrons. Okay na? 30 neutrons. Next, how many electrons should be there? 26 electrons. Okay na children? 26 electrons. If you observe, here also in case of iron, number of neutrons are more than number of protons. Okay na? Number of neutrons are more than number of protons. Okay na children? So if it is having like this specifically, that is number of neutrons are more than number of protons, then we call it as isotopes, that we discussed in the previous class na, isotopes. Okay, that means element which is having more number of neutrons compared to okay, see children, so carbon has atomic number 6 and sodium has atomic number 23. So in carbon atom we have seen that is 6 and 14 neutrons. So that is, I already told you now, allotropes. So carbon is found in different forms, that is as a diamond, okay, Buckminster fullerene, graphite, all these things are forms of allotropes of carbon. So number of neutrons will be changed automatically. So see here, carbon atomic number 6 and atomic mass is 14. So 8 neutrons, 6 protons, 6 electrons. Okay na? Now, so an element found with a different number of neutrons having same atomic number, such kind of elements are called as, what do we call them? Isotopes. Okay na children, what do we call them? isotopes. Okay na? So with this I hope you understood. So generally isotopes, in the sense they're having some chemical properties same, but because of change in the number of neutrons they may have some other chemical properties are different, especially like radioactivity. Okay, in those case they will be differing. Okay, similarly sodium. So one sodium atom is having atomic mass as 24 and another is having 22. So both are having same number of protons and same number of electrons. So only difference is having number of neutrons. In one it is 11, in another one 13 neutrons. Okay na children? Yes, like this there will be some difference in their number of neutrons. So as there is change in the number of neutrons, some chemical properties will change. Okay na? So generally an atom with the same number of atomic number, different number of protons having same atomic number are generally called as isotopes. That you should remember first. Isotopes in the sense same atomic number, different neutrons. Okay na? Next, protons, nucleus, electrons, shells, isotopes, all this we covered. Okay na? Okay children, now with this I hope you understood. So protons, that is mass. Okay, what is the value of protons mass? So 1.673 into 10 power minus 27 kg. Okay na? What is the mass of a proton? 1.673 into 10 power minus 27 kg. Actually they are very very small. Atom itself is a small thing. So again inside the atom there is nucleus. Again in that nucleus we are having protons. Similarly neutron, 1.675 into 10 power minus 23 kg. Okay na? So my 10 power minus 27 kg, sorry, 1.675 into 10 power minus 27 kg. So this is about proton neutrons mass. Coming to electron mass, generally there is no need of discussing electron mass. Why? Because it is almost all negligible. No need to consider the electrons mass. Okay, and it is very very small compared to both neutron and proton mass. Okay na? So charge, what is the charge of a proton? Positive charge. Okay na? What is the charge of a proton? Positive charge. Okay, that is equal to 1.67 into 10 power minus 19 coulombs. Coulombs is the unit of charge. Okay na? And electron is having a negative charge which is equal to minus 1.67 into 10 to the power of minus 19 coulombs. Okay na children? This is the charge of a proton and electron. Okay na? Next, well, next one, Seema. Charge of a electron. What is the charge of a neutron? It is neutral in charge. There is no charge. That is why I wrote here 0. Okay, neutral charge. Okay na children? So generally on the whole you can write it as +1 and -1. Okay na? Charge, unit charge. Okay na children? Have you understood how to represent? We are generally rounding of figures here. That is 1.67 into 10 to the power of minus 19 coulomb. You can write it as approximately +1. Okay, that is unit positive charge. So this is all about our what is inside atom, children, and some other important questions like what are Bohr's postulates, okay, and how electron was discovered, how neutron was discovered, how proton was discovered, what are the gold foil experiments explained, J.J. Thomson model, Rutherford's experiment, all these things you need to just go through this. That is how it was discovered. Okay, those experiments are important for you